Just outside the focus knob on the left side of the instrument are another important cluster of buttons which perform different functions on the microscope. We'll discuss the intensity of the illumination, we will discuss the aperture diaphragm, we will discuss transmitted light or reflected light illumination, and we will also discuss a field diaphragm that's only used for fluorescence. As discussed previously, the transmitted light illuminator of the microscope comes on automatically when you turn on the power. It comes on at full intensity. And so to turn down the intensity of the transmitted light illumination, you use these knobs on the side of the microscope labeled intensity, and you turn down the illumination this way. Line 3 of the screen shows you a bulb, and it shows you the intensity of that bulb, and you can lower the intensity again by pushing down on the button. It's a good idea to keep the intensity low when you're not looking through the microscope to save the life of the bulb. Also, as discussed previously, on the upright compound microscope, we have an aperture diaphragm in the system. The aperture diaphragm is a diaphragm that gives us contrast and depth of focus. The aperture diaphragm can be increased in opening and decreased in opening by actuating these two buttons. On the illumination line of the screen, the aperture diaphragm is displayed and the size of the opening is displayed. And as I actuate the button, you can see the aperture diaphragm closing down. The aperture diaphragm should be closed 2/3 of the way down. We will show you momentarily how to look down the tube of the microscope to know where your aperture diaphragm should be set. On the front panel of the microscope are two buttons that direct the light to observation or to the camera, which is built into the side of the microscope. You shouldn't be manipulating these buttons unless you need to do photography right off the microscope. The second to the last line on the screen shows the beam path and whether it's directed to the camera or for observation. And so by actuating the observation camera button, you can see that 100% is directed to observation or 100% is directed to the camera. Once again, on the left side of the microscope, the very bottom line is the transmitted light, incident light button changer. So you can push this and go from your transmitted light selected observation to your fluorescent incident light illumination. When you switch from transmitted light to incident light, this is shown on the top line of the screen. And so you can watch the screen change from transmitted light to incident light fluorescence and back to transmitted light again. As mentioned previously, curler illumination or alignment of the light path to the optical path in the microscope is very important. You must do it for each objective that you're working with. To do this, we're going to use features of the illuminator. We're going to manipulate the field diaphragm. We're going to manipulate the height of the condenser by turning the knob up and down. And we're going to use these two alignment tools to align the condenser to the optical path. In discussing curler illumination, it's important to understand how the lamp is affecting your image and how the condenser is centered to the optical path of the microscope. Here on Nikon Microscopy U, we have a nice little tutorial under curler illumination that shows you both the filament alignment and the condenser alignment. So let's go through this tutorial. Here you see the actual filament which shows up in the field of view. Now in modern microscopes it's not as important to do this because the modern bulbs are already pre-centered, but here what we can do is we can focus on the filament, make sure it's nice and sharp, we can rotate it, and we can also align it in X and Y so that it's fully aligned to the center of the microscope. Again, you shouldn't have to do this with modern microscopes because the bulbs are pre-aligned, but it just gives you an idea of how important the lamp is to the illumination of the microscope. Now let's discuss the condenser alignment because this is how you actually do curler illumination. In condenser alignment, you see your field of view that you would see through the microscope. The first thing you do is you put a specimen on the stage and you focus at 10x objective. So here you see your specimen, and we can focus on this specimen by actuating this fine focus knob. And you can see that image go in and out of focus. So on 10x objective, we highly focus our specimen. We open our aperture so that we can see the opening of the diaphragm. We do that with this knob right here. And as you can see, the diaphragm is, number one, not focused. We need to see the leaves of this diaphragm nice and sharp. And so we manipulate our condenser height with that silver knob so that we can focus in and out on these leaves. And so you see at the center point here, those leaves are now nice and sharp. But we also notice that the field diaphragm is not centered to the field of view. So we can translate by moving the knobs on the condenser. We can move the field diaphragm from side to side and up and down in the field of view. So the goal is to align this condenser as much as possible using the field diaphragm. Make sure that it's aligned to the whole field of view. It may take you a few turns of these knobs in order to align it perfectly. And then once it's aligned, we open the diaphragm just outside the field of view. Now your microscope is fully centered both optically and with the light path. Now let's align our condenser using the condenser alignment tutorial. To do that, we click on this condenser alignment tutorial, and you see here your field of view in the microscope. The first thing to do when you're doing color illumination is to use the 10x objective and to get your specimen finely focused. So we'll use this sliding bar to get our specimen in the field of view finely focused. Now you close down your field diaphragm, which you can see here, so that you can see it in the field of view. And so we want to close it down enough to where we can see almost the whole diaphragm. It's also important that these leaves be nice and sharp. Here you can see that they're somewhat defocused. So we move the condenser height up and down until we get nice sharp leaves on the field diaphragm. Now we can see our leaves nice and sharp in the field of view. But we still have to align our field diaphragm to the field of view. And we do that by the alignment tools that are provided on the side of the microscope to move the condenser to left and right and up and down. And so by manipulating these knobs, you align your condenser using the field diaphragm to the center of the field of view. You get it as aligned as you possibly can, and then you open the diaphragm to just outside the field of view. Now your microscope is aligned both optically and with the light path. In order to do color illumination in the microscope, we first put our slide on the stage, we dial the 10x objective into the beam path, and then we lower the condenser into place, also in the beam path. Now we focus our specimen on 10x, we close our field diaphragm down until we can see it in the field of view. Then we raise and lower the condenser until those leaves are nice and sharp. We align the field diaphragm to the field of view using the two alignment knobs, and then we open the field diaphragm just outside the field of view. Now our microscope is aligned at that objective. There are three modes of illumination that we use for transmitted light in the Leica confocal microscope. The first one is bright field, as you see here. It's simply light passing through your specimen, which in this case is stained. If you're looking at live cells which have been cultured and you look at them in bright field, they might look something like this. And so bright field is not the preferred transmitted light technique for looking at living cells. Differential interference contrast is a very wonderful optical staining method, and it allows you to get a three-dimensional image of your cells by using a combination of polarized light and what are called Wollaston prisms. And so your cells show up very nicely in DIC, which we have on the confocal microscope. Another form of contrast, optical staining method in the microscope, is phase contrast. We do not have phase contrast on this microscope. However, I wanted to show you the difference between phase contrast on live cells and DIC. DIC looks like this with live cells. Phase contrast gives a lot more contrast, but sometimes it's not as useful as DIC. So your preferred methods of illumination and viewing in transmitted light are DIC and bright field. Before we end this session for today, I wanted to show you using the computer screen the difference between DIC, or differential interference contrast, and bright field microscopy. These are both transmitted light illumination methods, and sometimes DIC can be a little more useful than bright field depending on the specimen that you're working with. Now, the slide that I have on the microscope today is probably not the best slide to illustrate this, but you will see this as you work with the microscope. So we're going to focus now on the monitor, and you see an image. This is a bright field image of a thin section of plant material, and you can see the individual cells, and inside one of these cells you see the nucleus. So in bright field it's fairly well illuminated, and however, bright field sometimes lacks as a contrast method. So bright field is one method of transmitted light illumination that you will use, and the other is DIC, or differential interference contrast. So I'm going to change some software tools here, and you will see the difference when we go to a DIC image. And now you have differential interference contrast, and you can see that there might be a little bit more contrast in the cell that you're looking at. However, because of the polarized light nature of the cell walls, all of these glow highly in this slide. But if you're growing live cells on cover slips or in a culture plate, sometimes Nomarski is a better way of imaging those cells in a transmitted light method. As mentioned previously, we have an attachment digital camera hooked onto the camera port of the microscope, so we can take pictures right off the microscope if that's your desire. And so we can direct the beam path to go from the viewing port down to the camera port, and by connecting this to a laptop via a firewire cable, we can take pictures right off the microscope right onto a laptop. As mentioned previously, we have a combination of wet objectives and dry objectives on the Leica confocal microscope. In order to go from a dry objective to a wet objective, we must first rock the condenser out of the way. You can see the specimen on the stage. We rotate the nose piece until we get the wet objective almost in place, and then we add a drop of immersion oil to the front lens of the objective. We want just enough oil to cover the front lens, and then we rotate the nose piece fully into the optical path, and you can see now that the front of the objective is wet, touching the cover slip of the slide. This is how you use an oil immersion or glycerin immersion objective. Before we end our current session, it's important to follow proper shutdown procedures for using the light microscope. The first thing we do is we rotate our condenser out of the way. We take our specimen off the stage, set it aside. We dial our nose piece all the way down past the 10 objective to the blank spot and put the condenser back in place. Now the microscope is ready to be powered down. Do not forget to turn off the mercury burner before you turn off the microscope. This is a very expensive bulb, and the waveguide gel is very expensive. One person already left it on over a whole weekend, and we had to replace a $500 bulb. So turn off the power on the front of the mercury burner lamp house. Because the main power to the system also turns on the computer, Windows starts by itself. Therefore, in shutdown, you must first close Windows before you can turn off the power to the system. So we close Windows, and we wait until Windows shuts down completely. To turn off power to the system, you now depress each button in the reverse order to which you turn them on. So from right to left until all the power is off. finally, to protect our microscope, we use the dust cover to keep dust and debris off the instrument while it's not in use. I want to thank you for your attention during the presentation of these videos. We want to thank the Keck Foundation for their generous financial support, which allowed us to produce these videos, and also thanks to Nikon Microscopy University for the wonderful images that we've been able to display during these videos. Thank you, and see you soon.